and so I will move to the last question, which is about detecting the outliers using the median and the MAD. So again, what I will do, you can just start from scratch, and this is what I'm going to do here so that you can see. So I will start from the other function here, outlier detection, but we know that for that function, I'm using the average and the standard deviation. So this is not what is asked in that new question. So what I'm going to do, I will create a new function that I will call outlier detection MAD, for instance. I know that the input are exactly the same because the only changes that I will have in that function is the unconditional mean that I will change, so the average that I will change, and I will change also the standard deviation. So instead of having the average, I will put here the median. So what is the median? We have seen how to compute the median for an array. This is just np.median. And so you see that here I'm putting ret. Why do I put ret? It's because when I will call that function, for that function, the array is called ret. This is the input. And so here I have, I'm just using the median. Perhaps I can change the name because otherwise it's a little bit disturbing. Median of ret, that's that one way. And so I will have to change, of course, where unconditional uncmean appeared in that function before. So now we have changed. Sorry, there is the n that is missing, and so now the same thing for the standard deviation. I want to change the standard deviation by the MAD. So the MAD, we know that it is not exactly equivalent to the standard deviation. We have to multiply the MAD by 1.48. Then I will multiply by the MAD. The thing is that the MAD variable, let's say I will call it MAD ret, this MAD variable does not exist. So I have to create and to compute the MAD of my array ret just before calling it to compute the standard deviation. So what is the MAD? Again, I can just code it from scratch, or I can go back here because I have already estimated this MAD, and so I will just copy and paste my estimation. The thing is that again, here draws does not exist in that function. It exists in the code here, but in the plain code, but it does not exist in that function. The array in that function that exists is ret. So I have to change here and put ret so that I can have the correct result. So here I'm just computing the median. I could have changed it like this. I will do that. It's a little bit easier to read after that. And so now this should work. And so I have a new function that is able to detect outliers, but now using the median and the MAD as quantity. So the median for replacing the average and the MAD for replacing the standard deviation. So what I'm going to do, I'm going to call that function with draws as an input. So this is the new function. Does it work? Great, it works. So I have just pressed F9. And now I can just, again, make the draws. So everything will work here because you see that I have just replaced the output that I got from outlier detection by the output that I got from outlier detection MAD. So the new output that I got from my new function here. And so below you see that I'm still calling output, but that's nice because this output has been changed. And so here I can just again make the plot. And so you see that I have many more outliers that have been detected. This is what we have discussed in class. It makes more sense because typically we have chosen here a threshold that makes that at least on average that means that on average 5% of the observation should be outliers. And so you see that here, this is what I have on average. You also have to count to add to that 5%, the 5 outliers that we have added. Let's have a look to the number of outliers that we have. So if I look at the output of my function, so you see that I have first the lower bound. If I want to call it, I just put in bracket and I say that I want the first element. The first element is the lower bound. The upper bound is the second element. This is what I have depicted on this graph. And finally, you have all the indices of the outliers that have been detected by the procedure. So now what I can do, I can just have a look to that final array. So you see that here I made a mistake. So the index of that array is not 3, it is 2. So of course the dimension of output is 3, but the indices start, or the index start at 0 in Python. So here to get this value I have to put 0, for getting this value I have to put 1 in brackets, and for getting this array I have to put 2. And so here you see that I have access to that array. So now if I want to just count the number of outliers, so here I know that these are the indices of the outliers, and so I can just count the number of indices that I have here, so that I can just have an idea of the number of outliers that I have detected. So for that you can call either size, or you can also call shape, as I did before. I prefer shape because shape tells you more about the shape of the array. Because here, for instance, you see, when you see the output, you see that I have 38 observations in the first dimension for the first column, but it also tells me that I do not have any more other columns. So I only have one column. So here for the size, it will stack all the columns together, and then it will count all the elements in your array. So let's say that you have a matrix of 100 by 2. Then if you ask the size of that array, it will tell you that the size is 200, which is a little bit misleading, because in fact you have 100 observation per column. So it's always better, I think, to work with shape, because with shape you have a very good idea of what is exactly the dimension of your array, because in that situation shape will tell you that you have in the first dimension 100 observation, and then you will have here after the comma you will have 2. Let's try to show that to you. For instance, here I'm going to create an array of only a field of zeros, but it will be a matrix of 100 times 2. So the dimension will be 100 by 2. And so now if I call, for instance, size for that array, let's say that I call that array, let us give a name, let's say var. This is my variable where you have all these zeros. And so now I want to know the size of this. Okay, yes, this is not correct. So var will be np zeros 100 by 2. So here I have this matrix of 100 by 2. So now I want the size of it. So you see that size tells me that the size is 200. So I think that it's a little bit misleading, because at the end, if I just go at the index 120, I think that it will work, and it doesn't work. So you see that it's clearly misleading, because it tells me that I have a size of 200, but if I want to have access to the element 120, you see that it doesn't work. And why it doesn't work is because this is a matrix. So if you want to have access to that element, in fact this is the 20th element in the second column. So this is of course 0, because this variable is only filled by zeros. So here, if you use the shape, on the other hand, what you will get 100 by 2. So here you see that that's exactly what you have created, and so you can understand that Of course, you can have access to the first and the second column. If you want to have access to the second column, this is a comma 0. So let's say that I want to have access to the second element of the first column. This will be how I can have access to it. So yes, that's it for this exercise. I hope that it was helpful to you, and see you next week for the next course. Thank you very much, and goodbye.